Hi everyone. Today is the second video of this paper, question paper 43, paper 4, variant 3, October-November 2019. The first part of the video, I discussed the first 4 questions, and in the second video, I'll discuss question number 5, 6, and 7. So let's start. Okay. Question number 5 is: a cyclist is traveling along a straight horizontal road. The total mass of the cyclist and his bicycle is 80 kg. His power output is constant, 240 watts. His acceleration when he is traveling at 6 meters per second is 0.3. Show that the resistance of the cyclist's motion is 16 Newton. Okay. So, as we know that first of all we'll write the data given in the question. The mass of cyclist is 80 kg. The power is 240 watt. Acceleration is 0.3 meters per second square, and the speed is 6 meters per second. So we know that the formula P is equal to Fv, power is equal to force into V. Here the F is the driving force. So put the values. Power is 240 is equal to driving force we need to find, and to velocity is 6 meters per second. Now this will become 240 over 6 is equal to Fd, or Fd is equal to, this becomes 40. So Fd is 40 newtons. Okay. As we know from the second law of Newton, resultant force is equal to ma. So as you all know that the resultant force is actually driving force minus force of resistance is equal to ma. So driving is 40 newtons minus force of resistance is equal to mass is 80, and acceleration of the cyclist is 0.3. So this becomes 40 minus force of resistance is equal to 24 newtons. So take 24 on the left and Fr on the right. It will become 40 minus 24 is equal to Fr. So force of resistance will be 40 minus 64, which is 16 newtons. This is our answer of part 1. Okay, now the second part. Find the steady speed that the cyclist can maintain if his power output and resistance force are both unchanged. So again we'll use the power formula of power. P is equal to Fv, since this is driving force, since the speed is steady, speed is constant, it means there is no resultant force. That's why Fd is equal to Fr. means forward force, driving force is equal to backward resistance force. So the Fr is 16 Newton, that's why our driving force will be 16 Newton as well. So just put the value here. Power is same, power is unchanged, that means power is 240 and Fd is 16 into V, that's why V is 240 over 16, which is 15 meters per second. So this is the answer of part B. Part 3. The cyclist later ascend a straight hill inclined at 3 degrees to the horizontal. So there is a hill. I'll make the vector diagram first. Angle is 3 degrees. Let's suppose this is the cyclist. Okay, his power output and resistance force are still unchanged, means his power is 240 watts and force of resistance is 16 newtons from part 1. Okay, his power out unchanged. Find the acceleration when he is traveling at 4 meters per second. Now the speed is 4 meters per second. We need to find acceleration. Okay, so for this vector diagram, the weight of the cyclist actually acts downwards. What is the weight of the cyclist? The mass is what is the mass? So mass is 80 kg, so the weight will be 800 newtons, and this will be the horizontal component of weight, which will be 800. This is also 3, 800 cos 3 degrees, and this is the vertical component of the weight acting downwards, which is 800 sine 3 degrees, and this is the normal reaction in the upward direction. So this is the vector diagram for the question. Now we know the formula for the power. P is equal to FdV. Now we need to calculate Fd, mean driving force. So Fd will be power over speed. So Fd power is 240 and speed is 4 meter in this case. So this is 60 newtons. So the forward driving force is 60 newtons. Okay, now again from Newton's second law, F is equal to ma. This F is resultant force. So what is resultant force? Please keep in mind one more thing, that the force of resistance, which is 16 Newton, that is also acting downwards. So the two forces are acting downwards. One is the vertical component of weight and the 16 Newton resultant resistance force from the part 1. This is also acting down, and the driving force is upward. So the resultant force will be 60, this 60 minus 16 minus this 60 minus 16 minus 800 sine 3 is equal to mass is 80 and acceleration we are going to find. So putting 80 on the left side, 60 minus 16 minus 800 sine 3 over 80 is equal to A. Therefore, A will be, by solving all this with the calculator, 0.0266 meters per second square. This is the answer of part 3. Question number 6. Particle P travels in a straight line from A to B. The velocity of P at time t seconds after leaving A is denoted by v meters per second. This is the expression for velocity. P takes 5 seconds to travel from A to B and it reaches B with the speed 10 meters per second. The distance AB is 25. These three things are given. Number 1 is given, time is 5 seconds. Number 2, speed at B is 10 meters per second. And number 3, distance of AB is 25 meters. All these things are given. We need to find the values of constants C and K. Okay. So we are given with the relation V is equal to 0.04 t cube plus ct square plus kt. Okay. By putting the values T5 and V10, by putting T is equal to 5 and V is equal to 10 meters per second. Both values here. So this will become 10 is equal to 0.04 into 5 cube plus C into 5 square plus K into 5. Okay. So this will become 10 is equal to 0.04 into 125 plus 5 square is 25c plus 5k. So 10 is equal to 0.04 multiply 125 is 5 plus 25c plus 5k. So take 5 on the left. 10 minus 5 is equal to 25c plus 5k. So I will get 25c plus 5k is equal to 5. I can take 5 common. So 5 is 5c plus k is equal to 5. So this 5 cancelled. So the final equation will be 5c plus k is equal to 1. This is equation number 1. Now again I will start from the expression V is equal to 0.04 t cube plus ct square plus kt. Now as you see, the distance is also given. It means you should figure it out that I need a distance as well. So the second expression will be of distance, from which I will get the second equation. So I will extract distance from this expression. I know that speed is actually ds by dt is equal to 0.04 t cube plus 3 ct square plus kt. So take dt on the other side. This will become ds is equal to 0.04 t cube plus ct square plus kt into dt. Okay, now by taking integration of both sides, so this will be ds is equal to 0.04 t cube plus ct square plus kt dt. Okay, now this will be s is equal to, the integration of this part will be 0.04 t4 over 4 plus ct cube over 3 plus kt square over 2. Okay, now this will be 0.01, so s is equal to 0.01 t4 plus ct cube over 3 plus kt square over 2. Okay, so I'll not take constant here because at time 0 the distance was 0, so the constant will also be 0. That's why I'm skipping that constant of integration here. So by putting t is equal to, at t is equal to 5, distance was 25. So put these two things here. So this will become 25 is equal to 0.01 into 5 power 4 plus c 5 cube over 3 plus k 5 square over 2. Okay, so this will become 25 is equal to 0.01 into 6 to 5, 5 power 4 is 6 to 5, and 5 cube is 125, so 125 over 3c plus 5 is 5 square is 25, 25 over 2k. So this will become 25 is equal to 0.01 multiplied 6 to 5 is actually 6.25 plus 125 over 3 means 41.7 c, and 25 over 2 means 12.5 k. So take 6.25 on the other side, so we'll get 25 minus 6.25 is equal to 41.7 c plus 12.5 k. So the final equation will be 41.7 c plus 12.5 k is equal to 18.75. This is equation number 2. So this is 1, this is 2. We'll solve them simultaneously in the next page. So our first equation was 5c plus k is equal to 1, and the second was 41.7 c plus 12.5 k is equal to 18.75. So if I multiply this first with 12.5 k, I'll be able to equalize the k's values, so they can be cancelled. So multiply 1 by 12.5. This is 1, this is 2. So this will be 5c plus k is equal to 1 multiplied 12.5. So this will become 12.5 into 5, this is 62.5 c plus 12.5 k is equal to 12.5. And the second equation, this is actually our third equation. And the second one, I'll write below this equation, 41.7C, this is the second one, plus 12.5K is equal to 18.75. This is equation number 2. So I'll solve them simultaneously. Sign change. So this will be cancelled. 62.5 minus 41.7 is actually 20.8. C is equal to 12.5 minus 18.75. This is minus 6.25. So now C will become, C is equal to minus 6.25 over 20.8. So which will give me minus 0.3. This is the value of first constant C. Now from 1, so I'll put the value of C in equation number 1 to get the value of K. So this will be 5 into C means minus 0.3 plus K is equal to 1. So this will be minus 1.5 plus K is equal to 1. So K is equal to 1 plus 1.5. So K is 2.5. This is the value of second constant K. So that was the part number 2. Now part 3. Show that the acceleration of P is a minimum when T is 2.5. Okay. So I got the expression V is equal to 0.04 T cube plus CT square plus KT. So I need acceleration, so I know that acceleration is dV by t, so dt. So I'll differentiate with respect to t. So by differentiating with respect to t, this will become dV by dt is equal to 0.04 into 3t square plus 2ct plus k. So this is actually okay, a 0. This will become 0.12 t square plus 2ct plus k. So for the minimum function I need the double derivative of d. So from here d2v by dt square, because for checking of the minimum or maximum function we need the d2v by dx square, dt square. So this will be 0.12 into 2t plus 2c. So this will be d2v by dt square is equal to 0.24t plus, to put the value of c here, so c is minus 0.3. So this will become 0.24t minus 0.6 d2v by dt square. So since we are talking about the minimum function, so I hope everyone knows for minimum function uh, always d2v by dt square is greater than 0. So it means this expression should be 0.24t minus 0.6 should be greater than 0. Okay. So 0.24t minus 0.6 is greater than 0. So take 0.6 on the other side. 0.24t is greater than 0.6 or t is greater than 0.6 over 0.24. So t is greater than 2.5. It means the minimum value of t is 2.5 seconds because the t is greater than 2.5. So this is shown. This is the answer. Okay, the last question, question number 7. Two particles A and B have masses mkg and kmkg respectively, where k is greater than 1. The particles are attached to the ends of a light inextensible string. The string passes over a fixed smooth pulley and the particles hangs vertically below it. Okay, you can see the picture. Both particles are at height 0.81, this one, above the horizontal ground. The system is released from rest and particle B reaches the ground 0.9 seconds later. So the particle B will move downwards and particle B will move upward. This particle B will move downward, this will move upward. The particle A does not reach the pulley in its subsequent motion. Find the value of k. We need to find two things, the value of k, and show that the tension in the string before B reaches the ground is equal to 12 m Newton. Okay, so first of all, for particle A, particle A is moving upward from rest, so it means u is 0 meters per second. Okay, actually we don't need u. The upward tension is more than the downward weight, which is 10 m of the particle, because particle is moving upward. So by Newton's second law, F is equal to ma. So F means the resultant force, means upward tension minus weight, which is 10 m, is equal to ma. Or T is equal to, take 10 m on the right side, 10 m plus ma, or I can write it as T is equal to 10 plus a m. I can take m common. So this is my equation number 1. Okay, for particle B, so the particle B, particle is actually moving downwards, so its weight is 10 km and upward tension. Now actually the weight is more than tension because the particle is moving downward, so the resultant force will be 10 km minus T. So again we'll use F is equal to ma, where F is the resultant force, which is 10 km minus T is equal to ma, because 10 km is the weight of the particle B and T is the upward tension, so weight minus tension will be the resultant force. So take ma on the left and T on the right. It will be 10 km minus ma is equal to T, or I can write it as t is equal to, I can take m common, so it will be 10k minus a into m. This is equation number 2. So I have value of t in equation 1, so I'll put the value of t here. So from 1 putting value of t. So this will be, t is 10 plus a into m, so I'll put here 10 plus a into m is equal to 10k minus a into m. So m cancelled. So this will be 10 plus a is equal to 10k minus a, or one second, sorry, this is km because the mass is km. This is also km. This will be ka, ka. So take k common. So this will become 10 plus a is equal to 10 minus a into k, or k will be 10 plus a over 10 minus a. So this is equation number 3. Keep in mind this equation 3. So actually look at the total marks, and I got only this small space for the working. So this is very unusual from the British Council. The total marks are 7, and the amount of space is very small. I have to squeeze in my question. Okay, I can see that k is 10 plus a over 10 minus a. K is equal to 10 plus a over 10 minus a. I need to find this a. For a, I need to consider the movement of b again. So for particle b, listen, particle is moving downwards from rest. It means u is 0 meters per second, and particle covers this distance 0.81. So the distance is 0.81 meters, and the particle took 0.9 seconds. It means the time is 0.9 seconds, and I need a. So if I look closely, I can find the second equation of motion. S is equal to ut plus half at square. So S is 0.81 is equal to u is 0 into t 0.9 plus 1 by 2 a into 0.9 square. So this will be 0.81. This whole thing will be 0. So 1 over 2 a into 0.9 square. So take 2 on the other side. It will be 2 multiply 0.81 and 0.9 as well. That will be 0.9 square divided a. So which will give a is equal to 2 meters per second square. This is a. So I'll put this value of a here. So I'll get k. So the k will be 10 plus a means 10 plus 2. 10 minus a means 10 minus 2. This is 12 over 8, which is 1.5. This is the value of k. I need tension as well, so I'll put the value of k in any one of the equation 1 or 2. So I'll put in 1. So from 1, T is equal to 10 plus A, 10 plus 2 into M, 10 plus 2 into M, which is 12M. This is the answer of second quantity. So this is shown 12M. So this is shown, and I have found the value of K as well. Part 2. At the instant when B reaches the ground, the spring breaks. Show that the speed of A when it reaches the ground is 5.97 meters per second. Correct to 3 significant figures and find the time taken after the string breaks for A to reach the ground. So this part a little bit tricky, so you need to be very careful. Okay. First of all, I need to find the speed of particle B when before just hitting the ground. So for B, actually particle started from rest, so 0 meters per second. U acceleration, I know that is 2 meters per second square from previous part. Distance is 0.81 meters, it is given, and it is also given the time is 0.9 seconds. So these are all given. So I need to find V. So for this I will use V is equal to U plus AT, the first equation of motion. So V is equal to 0 plus 2 into 0.9. So V is 1.8 meters per second. Now this is the velocity of B when it hits the ground. So if you see the picture, the velocity of B before hitting the ground was V is equal to 1.8 meters per second. In the same way, the velocity of A was also same when the B hits the ground. It means its velocity, actually A will not stop because the string breaks. So due to inertia, A will move a bit forward, bit upward, and then come back. So when the B hits the ground, the speed of B and the speed of A was same. So it means for the upward journey after breaking of the string, the initial speed of the A was also 1.8 meters per second. So there are two parts of the journey from A to this point. When the B hits the ground, the string breaks. Due to inertia, A moves a little bit upward and then started moving downwards. So at this point, the initial speed was again 1.8. A's initial speed at this point and B's final speed before hitting the ground is same. So I hope you understand this. So for second part of journey of A after breaking the string, U is 1.8 meters per second, G is minus 10 meters per second because the particle is moving upward, and V is 0 because the particle will stop when it reaches the highest point. So I need to find the extra distance covered by that particles. So I need to find this distance. So I'll use the third equation. 2gs is equal to V square minus U square. So 2 into minus 10 into S is equal to 0 square minus 1.8 square. So minus 20 S is equal to minus 3.24. So S is minus 3.24 over minus 20. S is equal to 0.162 meters. This is the This is the distance covered by the particle A due to inertia. So if we see the picture again, so now this distance is 0.81. This distance is also 0.81 because the distance upward by A is equal to the distance downward by B. And this third portion's distance is 0.162 meters due to inertia which the A covers after breaking the string. So that when the particle A will start moving downwards, this particle will cover the whole distance 0.8 plus 0.8 plus 0.162. That is the downward distance covered by A. So the last portion, small portion, is the 0.162. I need that distance. Now for downward motion of A, because the particle will start from rest again, because at the highest point particle stopped, so initial speed will be 0 meters per second and G will be 10 meters per second square. The distance will be 0.81 plus 0.81 plus 0.162 as I discussed before. So this will be total 1.782 meters. This is the total distance covered by the particle A during downward motion. So we need to find the speed of the particle before hitting the ground. So for this we'll use 2gs is equal to v square minus u square. So 2 into 10 into 1.782 is equal to v square minus 0 square. So v square is equal to this will be this whole will be 35.64, and by taking square root v will be 5.97 meters per second. So this is the velocity of the particle A before hitting the ground. So we need to find the second thing. Find the time taken after the string breaks for A to reach the ground. So we need to find the time taken by the particle before it's hit the ground. Okay, so if you see the picture again, at this point the string breaks. So it means the particle A will move a bit upward and then downward. So we need to find the time of this portion and this whole flight. So this time we need to find. So we'll find time in two parts. First of all, the this portion's time, and then from this to this portion time. So finally we'll add these two times. Okay. For upward motion of A, first of all we'll find the upward motion time. For upward motion, we know that u is 1.8 meters per second, g is minus 10 meters per second square, v is 0 because the particle will stop at the top point, and distance we found is 0.162 meters. So now we can find the time, upward time, which is this will be v is equal to u plus gt. So 0 is equal to 1.8, g is minus 10, so minus 10 t. So take this minus 10 on the left side, 10 t is equal to 1.8. So t is 1.8 over 10. So t is 0.18 seconds. This is the time 1 for upward journey, because the particle move from here to upward and then move downward to the ground. So this is upward journey. For this journey the time is 0.18 seconds. Now I'll find the time for this journey. This will be for downward motion of A. Now the particle will stop here and then move back, so u is 0, and g will be plus 10. Particle is moving towards the gravity. Distance is 1.782 meters as in the previous part, and time we need to find. So I'll use the second equation of motion as equal to ut plus 1 by 2 gt square. So this will be s is equal to 0 into t plus 1 by 2 into 10 into t square. So s is 1.782 is equal to 1 by 2. This will become 5 actually. So 5t square. So t square will be 1.782 over 5, and this will be 0.36. So after taking square root, t will be 0.6 seconds. This is actually the second time. Okay. So this is t2, which is 0.6 seconds. So total time will be this plus this, the total flight time. So total time of A will be t is equal to t1 plus t2, which is 0.6 plus 0.18, 0.78 seconds. This is the time for the particle A. This is the answer. Okay. Part 3. Sketch a velocity time graph for the motion of particle A from the instant when the system is released until it reaches the ground. Okay. We know that actually there are 3 phases of the motion of the particle A. The first was when the particle B was moving downwards and the particle A was moving upward. So we know that from the previous part that velocity of particle B when it hits the ground was 1.8. So velocity of particle A was also 1.8 when the string breaks. So let's suppose this is 1.8. This is the acceleration. When the particle reaches at the velocity of 1.8, the string breaks. When the string breaks, particle decelerated for some time and then stops at the highest point. This is the highest point, and this was like 0.9 seconds. So at this point the particle was at the highest point. Now the particle started moving downwards, and we know from the previous part, this one, when the particle before hitting the ground, the velocity of the particle was 5.97. So this is 5.97 almost, and the particle took 0.78 seconds to reach the ground. So We'll add 0.78, it will be almost 1.7. Yeah, 1.7, and the particle's velocity was 5.97. So this graph will come downwards like this. So this is the point where the particle hits the ground. This is 5.97. Minus means in the other way, backward direction, and this is the time. So at time 1.7 seconds the particle actually hits the ground. So this is the graph of particle A throughout the flight of the time. So that's it for the paper 43, October, November 2019. So thanks for watching. See you in the next video. Thank you.